I have drawn up here 3 carbon chains. Let's go through these and name them really quickly. I've got a 1, 2, 3, 4, 5, 6 carbon chain. This is going to be a hexane. I've got a 7 carbon chain here. This will be a heptane. And here is an 8 carbon chain, octane. Notice under each of these I have a hexagon, a heptagon, and an octagon. These are also going to be carbon chains. Our carbon chains can and often do swing around into a cyclic structure. In order to name these, it is very simple. All we're going to do is attach the word cyclo in front of the carbon name. Here I have 1, 2, 3, 4, 5, 6 carbons. So this will be cyclohexane. Here, 7 carbons in a ring. This will be cycloheptane. Here, I've got 8 carbons in a ring. Cyclooctane. Nice and simple. Very straightforward. But of course, it'll get a little more complex from there. What if I added just a little methyl group? Just something sticking off the end here. Let's add one right here. Well, on hexane, this would become 3-methyl hexane. So I'm going to number from one side or the other. On my cyclohexane, if I add a methyl group, no matter where it is, when I start my numbering, I'm going to start from that constituent. Now, this is going to work the same way with every functional group as it did before as far as priority goes. An aldehyde will take precedence over an alcohol, which will take precedence over an amine. However, to name this, I'm just going to number that. Since it's the only functional group, it's automatically 1. And then going around the circle 1 through 6. So this will be 1-methyl cyclohexane. Straightforward. 1-methyl cyclohexane. Now, if I have multiples, let's put these on. Let's go a methyl group here, ethyl group here. Which direction do I number it? Might seem obvious. 1, 2 right next to it. Okay. You're absolutely right. We're going to number from, well, this is really the more complex one, so this would be our number 1. But we're going to number so that our total numbers are going to be the smallest possible. Let's see what that means. Let's go through this and make sure that makes sense. So I could go 1, 2, 3, 4, 5, 6, 7. So this is 1-ethyl, 2-methyl. So 1-ethyl, 2-methyl cycloheptane. My total here, 1 and 2, my total, if I add these together, is 3, right? If I were to number this the other direction, let's use a different color for that. Still starting from the same 1, going 1, 2, 3, 4, 5, 6, 7. Then I would have a 1 and 7. I would have a 1-ethyl, 7-methyl. Add those together and you get 8. 8 is bigger than 3, so we should go with the 3. This seems really simple, and why would I go through this whole process for just these 2 functional groups? But when we start to get bigger and bigger functional groups and bigger cycloalkanes, then it's actually going to start to matter. We're going to have to be able to figure out what is our lowest number. We're going to have to figure out those priorities. So finally, for cycloalkane, let's toss on a more complex functional group. Let's do an alcohol and an amine. So I'm going to add, let's not put that on a methyl. That just complicates things. Let's keep it simple for now. So an OH on a, just sticking off the end here. And then let's do a binary amine, just with a methyl group here. So here, alcohol takes precedence over the amine, so this is my number 1. I need to number in a way, clockwise or counterclockwise, so that my total constituent count is the lowest number possible. Since I have 8 carbons here, I can count 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6. 4 is going to be less, so I'm going to count counterclockwise. Sorry. So this will be 1 for an alcohol, so cyclooctane 1 all. And then I'm going to have an amine group on the 4. So this will be 4 amino. And then a methyl group coming off of the amino group. So that'll be N-methyl. So 4 amino, N-methyl, cyclooctane 1 all. So these names stay the same. They don't get much more complex. We just throw that cyclo on there, and we name and we number either in clockwise or counterclockwise directions so that we get the smallest number for our constituents.